Okay class, now let's proceed to the separable equations. Okay, previously I have showing to you one example where dy dx equal to xy. dy dx equal to xy. Then I said this one is a separable equation. So the definition of the separable equation is if you have the differential equation and then the right hand side of the differential equation, you can separate between two functions. For example, you have one function of x and another function of y, which is you can what we call it put it separately over here. So we call it this one as a separable equation. So just like this differential equation, so is actually you will have dy dx equal to first is x and another one is y. This one we have the, for example, we denote as a gx and then this one as a function of y, so we call it as a separable equations. All right, okay, let's move to other equation, whether the equation given to you is separable or not. For example, if you have dy dx and we have 3x plus xy over y squared minus 1. So how to make sure how to confirm that the given function is a separable equation? So you need to separate between x with x and y with y. So according to this expressions, you can bring the x outside, okay, where you will have the numerator over here 3 plus y, and then you just put the denominator together with the terms of y. So according to this one is actually you already separate between x function and also y function. So conclusion is it's separable differential equation. Okay, so we will go further on how to solve the separable equation just like in previous example, but maybe this time it's quite difficult. Okay, if you have dy dx and then you have how to find this one, equal to 1 plus y squared. So how to solve this one? Okay, so since the terms over here it's already have term of y, so we can consider together the term given to you is hash y, which is the function of hash in term of y, and then you can consider 1 over here as the function of gx. So what will happen over here is you can bring the terms of y into the left hand side. So you will have this one dy and then you will have 1 dx over here. Okay, so when you already separate between y and x in x, then you can take it the integrations, both sides, left hand side with respect to y and then the right hand side with respect to x. So for the x right hand side is a very easy because of you will have a direct integration. You may refer the table given to you later in the module, or you may refer to internet. So integrate 1, you will get an x. All right, and then how to have this one? So you need to have a knowledge because of you may refer the table. Okay, the integration of 1 over 1 plus y squared will give to you the arctangent of y. Arctangent of y. And then with plus with c. And then in order to find the y-x, you need to bring the arctangent left hand side to the right hand side, so it becomes tangent, and then we have x plus c over here. So this is the answer. So it's actually in the separable equation. It's the same techniques, however you might facing the different expression which is need some knowledge to solve it. For example, how to integrate cos, sine, exponent, similar things. Okay. Once again, I would like to advise you kindly understand how to integrate the single terms, and also the method of integration, which is you might facing the equation that need to use the method of integration, where it might be either by parts, tabular methods, or even substitutions. Okay, now let's continue to solve exercise 1.12. If you are given the differential equation dy dx equal to x squared plus 2 over y, so you may check whether this equation can be separated or not, and then you may apply the separable technique to solve it. Okay, now let's try to move y to the left hand side, so you will get y dy, and then you will have x plus 2 over here dx. So it's a separable equation. So in order to solve this one, what you need to do is you need to taking the integration of both sides. So what you will have over here is you will have y squared over 2 for the left hand side, and then you will have x cubed over 3 plus 2x, and then I put directly c to the right hand side. So you will have remain y squared to the left hand side, and then you are bring the 2 to the right hand side, x cubed over 3 plus 2x plus c. And then what you can do it is you can expand, or you may bring the power of 2 to the right hand side directly. Okay, let's expand first. So you will have 2x cubed over 3 plus 4x plus 2c, and then you will have y squared to the left hand side, and then you can find the y as a dependent variable, then the solution of the differential equation, and then the whole thing to the right hand side becomes 2x cubed over 3 plus 4x plus 2c. So this is the general solution that you want to find. Okay, thank you.